This episode is brought to you by a collaboration between the Denver Museum of Nature and Science and the Field Museum in Chicago, Illinois. Back in 2004, at the ripe age of 14, I received an email that looked something like this. It was a picture featuring two massive, nightmarish creatures with enormous fangs and humongous legs. They appeared to each be as big as a grown man's thigh and looked like they could take off your finger. The description with the images mentions that they have a, quote, vertical leap that would make a pro basketball player weep with envy, and that they need to jump high enough to jump onto a camel and suck out its juices, and maybe even lay its eggs in its stomach.
The thing is, most of that isn't true. I mean, the animals are, it's just that the forced perspective makes them look huge. The biggest ones are only 6 to 8 inches. They're completely non-venomous, can't jump like pro basketball players, and even though they can run pretty fast, they still can't outrun you.
These are camel spiders, and there are more than 1,100 known species. They live in deserts all across the world, with the exception of Australia and Antarctica, and the oldest known species date back to 300 million years ago. It was around during the Carboniferous period and roamed the planet some 60 million years before the dinosaurs.
So even though these guys are super abundant and have been around for a really long time, there's still a bunch we don't know about them, which is why I came here, to the Denver Museum of Nature and Science, to talk to Dr. Paula Cushing. She's been studying these guys for nearly 17 years.
Paula is an evolutionary biologist and curator of invertebrate zoology. Her research focuses on arachnids, a group of animals that includes spiders and scorpions, but her specialty is in camel spiders. She's one of maybe 5 scientists in the world who is regularly publishing new discoveries on these relatively mysterious creatures. So we went to her lab to learn more about her work.
So why don't more people study them?
So they're really hard to study. They're hard to catch when you're in the field. They're really hard to keep alive in the lab. I started calling them the spawn of Satan because they seem to appear, you're out there in the desert, they appear out of nowhere, they disappear, they run like the wind, you try to catch them, you can't catch them, it's like a love-hate relationship that I have with these things.
So are they venomous? Are they toxic at all?
No, so they have no venom. They act like they could take you down. But they can't, so they're really pretty harmless. When I catch them, when I grab one by my hand, the big species, like what you're seeing under the microscope, they'll give you a little nip and you can feel it. And I scream like a girl when they bite me, but they're not strong enough to break your skin. Our skin is tougher than we think.
Can you just tell us a little bit about their interesting anatomy?
Sure, so one of the most remarkable things about these arachnids is their enormous jaws. The jaws of arachnids are called chelicerae, and they can move their jaws both this way and this way.
So side to side and
side
up
to
and
side,
down.
up and down, yes. And they'll grab the prey with using their legs, using their front appendages are called pedipalps. But they bring that insect close to their jaws, to the chelicerae, and then they just start tearing it apart. But they can't chew. So what they do is as with almost all arachnids, they vomit digestive enzymes onto the body of the prey. The digestive enzymes break down the muscles and the tissue, and then, like with other arachnids, they have a muscular stomach and they just suck in that pre-liquefied, pre-digested meal.
Oh, how appetizing.
Yes. And with males in the family that I study animals in the family Eremobatidae. And in that family, the males have no teeth on that upper jaw of the chelicerae, whereas the females, she has teeth on both the upper and the lower jaw.
So why does it seem like they chase after you?
So there are stories of soldiers in Iraq and Afghanistan who have been stationed there who claim that they're running after them, they're chasing them down in the desert. And I think what's happening is as the soldiers are working the desert, they're basically uncovering the daytime burrows of these animals. And when they're disturbed during the day, they don't like it. They don't like the sun. They're trying to seek out shade. So we think what they're doing is they're chasing after the shadow of the soldier. And by doing so, by running after the shadow, they're essentially looking like they're running after the soldier. They have this remarkable ability to maintain very high activity rates for very long periods of time. They have tracheal tubes, kind of like insects do. So those tracheal tubes are picking oxygen up through little holes in the exoskeleton into their body and are transporting that oxygen very efficiently all through the tissue of the body.
So as terrifying as they might seem, they're pretty harmless.
They're pretty harmless.
We don't know enough about them.
Yeah, what we do know is they're important predators in very dry, xeric desert environments. And deserts worldwide are habitats that are at risk from agriculture, from irrigation, from development. And so these top predators like the sulfugids, like scorpions, they're important in both controlling the insect populations that exist in the desert. They're also important food. So desert adapted birds, mammals, reptiles are using sulfugids as an important food item. It's important for us to understand, I think, more about the biology of all organisms on Earth. I mean, we have one planet that we share with millions of species, and we know so little about the biology of our neighboring species on this planet. Anybody can make discoveries about them. I mean, there's so much left to know about camel spiders. So that's the really satisfying part of studying these animals.
Yeah, I can get behind that.
Yeah. I think everybody should get behind that.
Yeah, camel spiders.
Yes. Arachnids. Yes.
Yes. It still has brains on it.